So the standards also would reflect the technical reality, meaning it's more attuned to your requirement on your local market. Meaning that this is what the industry needs. This is how we govern. This is how we try to make sure that the playing field are the same. Meaning, if I carry this particular standard, everybody will carry this particular standard, no matter whose company it is, what particular equipment they're using, it will meet that particular standards. Okay. So familiarity with the standards, if you're gonna look at, so some of these are you're quite familiar with. So we have your the ANSI, or the American National Standards Institute. So the ASTM, so the American Society for Testing and Materials, and we have the IEEE, the Institute of Electrical Electronics Engineer, the AEIC, the Association of Edison Illuminating Companies. This is more of the utilities from the United States. So, and you have NEMA, so the National Electrical Manufacturers Association. This is more on the manufacturers from their particular, from the United States. And ISEA is the Isolated Cable Engineers Association. This is the cable arm of NEMA. So they develop mostly the cable requirements or the cable standards. And of course, the common known is UL also, the Underwriters Laboratory. So this is more of a testing laboratory. So they also develop standards in testing and the and some specifications on some of the materials used within the United States. Okay, on the other end, so if you're gonna look at the European side, so you commonly would have the IEC. So this commonly what is being referred as the international standard. So that's the International Electrotechnical Commission. So then CINELEC. So CINELEC is the European Committee for Electrotechnical Standardization, which majority of the IEC standards were taken from. So you can see IEC standard and EN standards will comprise sometimes the same number because the IEC standards mainly were derived majority from the CINELEC standards. So another most common are the British standard and DIN. So that's from United Kingdom and Germany. So the others, AFNOR, SEBEC, ENOR. AFNOR is from France, SEBEC is from Belgium, ENOR is from Spain. So sometimes you're not familiar with this particular standard because majority are already using IEC. So they have already unified or harmonized most of their standards with that of the IEC standards. Okay. Okay, so here is when you say what would be the common difference between the American and the European. Voltage classification, you have already a problem there. So in terms of medium voltage, we know that the Americans are trying to, from the NEC, they're trying to upgrade it already to 1000. That is trying to harmonize with the IEC standards of equal to less than or equal to 1000 volts to be as classified as low voltage. So for the medium voltage, so the American can go from 600 up to 69 kV. So but the European, they would only go from 1000 to 35. Meaning once when you're referring to medium voltage, if you're using say 69 kV, then that's gonna be governed by a different IEC standards because for IEC that is already considered as high voltage. Okay, so you have your extra your high voltage for the American 69 to 230, and for the IECs that's 235 up to 230 kV. So then your extra high voltage, so 230 kV to 1100 kV. So for the European, it's going to be 230 kV to 1200 kV. So they don't have specifications for the ultra high voltage. So for the American, it says anything that's higher than 1100 kV, that is your ultra high voltage. Okay. So the various standards, first and foremost, you have to look at the voltage classification, because some of the European standard and American standards, the difference will come into play. Okay, so in the development standards, well, so IEC standards, well, this group is mainly composed of various experts from various countries, manufacturers, industry, academic, professional associations, compliance regulators, testing laboratories. So it's a various number of stakeholders. So that's why it takes so long for them to come up with one particular standard that everyone would agree. Okay? So with the Americans, they are more grouped on terms of association. Like say the one being made by NEMA. This is the electrical manufacturers. So you have one side specifying what the manufacturers want, and the other organization may specify what the utilities may want. Like for the medium voltage, we have one coming from ISEA and one coming from AIEC. So it's only recently that they already harmonized their particular standards. So for manufacturers, it's gonna be the lower band, meaning I can comply it based on this particular level of standards only. On the utility side, I want something that is much higher. So there's that something that already is not meeting the two particular standards. So they're already not in sync already. So lately they have already harmonized, meaning it's already NEMA, ISEA, and AIC standards for the medium voltage. So there are various standards available to compare with, but since I'm with TC1, so wires and cables, so I'll go with something which is familiar to me. So let's go with medium voltage cables. So their wire sizes, nothing will really match. So you have an AWG one and a metric size. It's not gonna match really. So if you're gonna use an IEC cables, mainly you're gonna get something which is a bit higher. If the original standards is an American, you're gonna get a size which is a bit higher than the previous American standards. So for lay length, well, they specify 8 to 16 times. So for IEC, they didn't require anything. So it's up to you whether you're gonna twist your cables or not. So here comes the, say when you try to do some testing. So if you're gonna twist your cable based on the particular lay lengths, meaning your resistance when you test the assembled wire, so the resistance is gonna be higher. So meaning if you single stand and you test that, that's gonna be your 100% in terms. But when you're gonna test a twisted cable, your length is gonna be longer because of that particular lay. So your resistance is gonna be about 102% of the single stand of the particular conductor. Okay, so for IEC, it seems it's the same whether you have the assembled cable or the single cable. It's gonna be the 100% when you measure the particular resistance. So when you try to measure this, you have to take say this particular difference between the two particular standards. Another is insulation. So the American don't specify PVC for the medium voltage. Okay, and they don't also have for IEC. On the other hand, they don't have a 3 retardant XLPE in their class and a class 3 XLPE and TR XLPE. So EPR they have both, but the Americans don't have an HP EPR. Okay. So for the BIL at 35 kb, so the Americans have a 200 kb BIL requirement, and for IEC is just 170 kb. So for test classification, so there sometimes when you gonna specify, so the American will say qualification test, meaning any new product for them to qualify and make sure they say that they can produce this particular product. These are more stringent tests, meaning this has a lot of tests in it for them to say that this product has passed all the particular requirements. Okay. For the European, they call this a type test. So for new suppliers, we would commonly require them to submit the results of their qualification test or type test. Okay. And for the usual, when they're already producing the product, meaning they have already proved that they're qualified or the product passed all the qualification test or type test, then the production test, this makes sure that in every production is within conformity to that particular standards. This is a more reduced number of tests. The American would call it the production test, while IEC would call it as the routine test. Okay, based on the cable, so when they're doing the conformity testing, so the hot set test temperature at 15 minutes. So for the Americans only at 150 degrees centigrade, and for the IECs that's going to be 200 degrees centigrade. Okay. Okay, and another requirement for the medium voltage cable will be water absorption test. So the American would have only 7 days at 70 degrees centigrade, and while IEC has 14 days at 85 degrees centigrade. Okay, the shrinkage, well, the American don't have any requirement for this, while IEC has a requirement of maximum of 4% after 1 hour at 130 degrees centigrade. So in terms of elongation, so after 7 days, the American specifies 200%, but at a lower temperature of 121. But the IEC would require 150%, 7 days at a much lower temperature of 100 degrees centigrade. So cold bend, the American specified negative 55 degrees, so that's not a problem for us. So, but the IEC only specifies negative 15 degrees. Okay, the heat shock at 1 hour for the Americans 121 degrees centigrade, and for IEC is 150 degrees centigrade. Partial discharge, each one requires the same voltage, which is about tested at 3.5 their UO, meaning their base to ground voltage. Okay, impulse test. This is the test that the American ICA doesn't have compared with the IEC, meaning you're subjecting to the cables in terms of its resiliency against, say, surges. So here, the IEC requires 10 positive and 10 negative impulse voltage. On the other hand, for the Americans are trying to ensure that the cable will be reliable.